So we've been talking about area for quite a while now, and we are going to continue today, and hopefully after that we can move on. But we've been using parallelograms and triangles to put that into practice. So we've been finding the area of parallelograms and triangles. So this first exit slip that we're going to look at, we are dealing with parallelograms. And initially we just talked about how to find the base and the height so we could find the area. So Linus, do you want to help me find the base and the height for this parallelogram here? All right, so first we'll find the base, B. So how long is the base there? Can you tell me? It's this. 1, 2, 3, 7. That is correct. All right. What about the height here? 6. That's right. Do you remember how we find the? Well, wait a minute. I'm getting ahead of myself. Sorry about that. But yes, that is correct. The base is 7 and the height is 6. And we got that by counting the number of squares there. So good job. What about for this one? What's the base? Four. Three, that's right. What about the height here? 6, that's right. Good job. And again, we found those just by counting the number of squares. And you remember, sometimes that height will fall outside of the shape because we can't draw the line all the way to where we need it to. So we can just draw an imaginary line out. You can't see it in this example, but that would allow us to draw a perpendicular line up to the point we need to draw it. So we'll go back to the first one, and since we know what our base and our height are, do you remember how we find the area? Our nice formula that we use to find the area of a parallelogram? Base times height, that's right. So if our base is 7 and our height is 6, what does that make our area? You have your calculator there? 42, that's right. All right. So what would our area be on this one if we know our base is 3 and our height is 6? 18. That's exactly right. You've got this down pat. All right. So can you see 6.1.6? All right. So we're going to find the area of this parallelogram again, but instead of us counting squares, or what they call on a grid, we're going to do this one off the grid. But they gave us the numbers that we need to find that. So which one do you think should be our base? The 9 or the 7.5? Do you remember what we talked about when finding a base? Which one would be easier to use? 9 is right. Now we can use any side we want for the base, but to make it easy on ourselves, we can choose one that goes straight up and down like 9 here, like you said, or one that goes straight across. So in this case, we don't have a line of the parallelogram that goes straight across, so we use the one that goes straight up and down. So 9, that's right. So we know our base is 9, so what is our height? Sorry, my screen's not capturing all that. 6, that's right. So what does that make our area? We know our base is 9 and our height is 6. $54, that's correct. So it'd be base times height, or 9 times 6, and that's 54. And we know that. We just went through that, so we don't have to explain our reasoning here. We've already done that. All right, so let's move on to the next one. 6.1.7. Is that showing up now? All right. So in this first example, we're going to pick which quadrilaterals we can decompose into two identical triangles just by drawing a single line from one corner to the other. So which ones do we think can do that? And I'll give you a hint. It has to be a parallelogram. Oh, I can't draw it on here, so we'll have to just use our head. B, yeah. C, yeah, that's right. Yes, that's correct. D. Can we draw a line on E? No, that's right. F, that is correct. So I wish I could draw the line on here, but if on B, C, D, and F, if we were to draw a line from one point to the opposite corner, we would be able to get two identical triangles. And like I said in my hint, it just so happens, that's our next question, are all of the quadrilaterals that we selected in question 1 parallelograms, true or false? Well, that's true, because in order for us to draw one line from one point to the opposite point in a shape like this, and to be able to get two identical triangles, it has to be a parallelogram. So nice job there. All right, let's go on to 6.1.8. And I'm all over the place. All right, is that up now? All right. So in this one, we're going to find the area of this triangle. Now, before we get into our nice little formula, we talked about finding the area of a triangle by creating a copy. And again, I'm sorry, I can't draw that out for you on this one. So we would make a copy, an exact copy of this triangle, and then we would move it and rearrange it, and then we could make a parallelogram out of it. And from there, we could find the area of the parallelogram using our base times height formula, and then just take half of it away. And that would give us the area of our triangle. So I'll do this one for you. So if we were to make an exact copy of this, we would then flip it around and create a parallelogram. So that would give us, I don't know, let me see if this will maybe help. So our rectangle would be shaped something like this. I hope you can see that okay. By see that, I mean in your head. Sorry. So that would give us a base of 1, 2, 3, 4, 5, and 6, and then a height of 1, 2, 3, 4 of a parallelogram. So if we know our base is 6 and our height is 4, what would the area of a parallelogram be with those dimensions? Mm-hmm. 24. And then if we had this drawn out, I could show you how we take that exact copy of the rectangle away to find the area of this triangle, or sorry, I said rectangle again. Take the exact copy of the triangle away, which would leave us our original triangle that we see here in blue. So if we take half of it away, what would the area of the remaining triangle be? 12. That is perfect. Exactly right. So how do we know that? Well, we talked about that together. So, all right, let's go on to the next one. All right, can you see 6.1.9? Okay. So based on what we just talked about how we found the area of that triangle using a parallelogram, we know the area of a parallelogram is what again? Base times height. So if we want to find the area of a triangle, and when we draw the line, we can make two identical triangles. If we want to find the area of one of those triangles inside the parallelogram, what do we know we have to do? If we know the area of the parallelogram, what do we know we have to do to find the triangle? Divide it by 2. That's right. So then, knowing that, is the formula for the area of a triangle 1/2 times base times height, or in other words, base times height divided by 2? Is that true? Yes, that's right. So to find the area of a triangle, we can use the formula base times height divided by 2, or sometimes you'll see it written as 1/2 times base times height. But whichever one's easiest for you is the one you can use. A lot of people use base times height divided by 2, especially when we're using calculators. It's just easier to type in. All right, so knowing the formula for our triangle, base times height divided by 2, let's find the area of this triangle together. So which one is our base? 5, right. So if we know our base is 5, what does that make our height? 6, that's right. So we know our base is 5, our height is 6. What is the area using our formula? Base times height divided by 2. Mm-hmm. 15, that is correct. So we multiplied 5 times 6, which is base times height, and that gave us 30. And then we divided that by 2, which gave us 15. Nice job. Let's do another one. So which one is our base in this triangle here? Three, that's right. So this one's a little trickier. Just like with parallelograms, we can pick any side of a triangle to be our base. But again, to make it easy on ourselves, we want to pick one that's either completely horizontal or side to side, or completely vertical, up and down. So in this case, we've got one that is completely vertical or straight up and down. So this is the one that they've chosen for us. And like you said, that is 3. The base is equal to 3. And when we choose a line, again, when we choose a line that's either straight up and down or vertical or straight across, side to side, or horizontal, that makes it easy for us to draw a perpendicular line to give us our height. So if our base is 3, what is our height here? 3, that's right. So knowing that our base is 3 and our height is 3, what is the area of this triangle using our formula? 4.5, that's right. So we know the area of a triangle. To get that area, we use the formula base times height divided by 2. Our base is 3, our height is 3. So that's 3 times 3, which is 9, divided by 2 is 4.5. Good job. All right, so we'll move on to the last one here. Can you see 6.1.10? Did that pop up for you? Can you still hear me, Linus? I think my microphone's messing up. Give me a thumbs up. Okay. All right, so in this first example, now we know the formula for a triangle, but now we're going to talk about again just how to find the base and the height. So remember what I said, any side can be used as the base, but to make it easy on us, we want to choose one that's either straight up and down or vertical or, or side to side or horizontal. So in this case, we have one that's completely side to side or horizontal. So we're going to choose that one. So our base is going to be the side that's labeled D. So if we know that our base is D, we know how to find the height. We have to draw a perpendicular line from the base to the opposite corner or the opposite vertex, which in this case is, here, let me turn my spotlight on, is here. All right, and sometimes you can draw that line inside the triangle, which you can do here, but they chose not to. But sometimes you can draw it outside the triangle. But in this case, they decided to draw it outside the triangle. So if we know our base is D, which one of these letters corresponds to our height? Is it E, F, or G? My microphone or I can't hear anything on this side. Can you type it in the chat for me? I'm sorry, I don't know. My computer's acting up this morning. Can you hear me? G, that's right. Perfect. All right. So now, all right, now we're going to use the area or our formula to find the area of this triangle. But this time they haven't given us the numbers that we need, so we're going to have to find them on our own. We're going to have to find our base and find our height. So which side of the triangle should we use for our base? Should we use the one on the left, the one on the right, or the one at the bottom? Which one do you think would make it easy on us? Left, that's right. So let's find what is the length of the line on the left. Six, that's right. So our base is going to be 6. So now what do we need to do? Can you tell me? Find the height, that's right. Now how do we do that? We have to draw a perpendicular line from our base to the opposite corner or the opposite vertex. So if we know this is our base, we have to go to the opposite side to draw our line to the opposite corner or the opposite vertex, which lies right there. So that, and I don't think I mentioned this today. I may have mentioned it in a previous video, but in order to make it easy, if we can draw it the line inside the triangle, I would suggest starting at the opposite corner and then drawing the line down to the base. I think that just makes it simpler on us. So if we were to draw the line from the opposite corner of the opposite vertex down to the base, that would make our height what? 4. So if we know our base is 6 and our height is 4, what does that make the area of this triangle using our formula? $12. That is correct. So our base is 6, our height is 4. We know the formula for the area of a triangle is base times height divided by 2. So that would give us 6 times 4 divided by 2 would be 12. So nice job. Okay, that was our last exit slip to go through. So do you have any questions for me, Linus? No. Okay. I don't know why I can't hear anything. I'm sorry that my computer's acting up this morning. But like I said, when we first started out, what I'm going to do is I'm going to get a quiz together that I will post for everyone. And on Wednesday, when we get together, we can ask questions about that quiz, or we can go through it and work on it while we're in class. So I will get that posted sometime later today.